Starting from the original video, the entire area is snipped to remove irrelevant sections of the image, like the sky and the trees, and anything that isn't generally the road. This is really convenient because it reduces the amount of processing required. There's just a smaller number of total pixels to look at. Next, anything that is not in the lane is masked. This is done by simply setting a trapezoid up with a list of points, but it does not adjust dynamically to when the car is moving. Next, any pixels that don't fall into the HSV color bound set for yellow and white lane lines are removed using bitwise operations. This image is blurred using a Gaussian blur to prepare it for edge detection. Next, the edges are detected using canny edge detection. Then CV2 Hoff lines is used to identify the straight lines in the edge detected image. After the straight lines are detected, the lines are filtered based on what angles are reasonable for lane lines. These lines are categorized into either a left or right lane bucket based on their angle. Using the median, row, and theta values for the left bucket and the right bucket, respectively, two median lines are plotted. This is repeated for each frame of the video. If no lane lines are found, then the previous frame's median lines are used. This is to give some insight into how left and right lanes are categorized. The plotted lines indicate the allowable angles for either the left lane lines or the right lane lines. There are quite a few improvements that could be made to this algorithm as well as the hardware involved in it. Hardware-wise, it would be good to reduce glare. The camera was mounted on the inside of the windshield, so there is glare from the windshield itself. It would be good to have a camera that's mounted such that there's nothing between the lens and the outside rather than having to pass through an additional windshield layer. It might also benefit the detection algorithm to shield the lens from the top to further prevent glare or apply anti-glare coatings to the lens itself. On the software side, the HSV boundary values pretty much dictate how well the algorithm is working. It dictates whether they decide the entire road is made up of just lane lines or whether white or yellow lane lines are detected at all. The HSV values for the yellow and white lane lines change pretty dramatically based on the time of day. So it could be interesting to set these boundary values based on the time of day that the car is traveling. It would also probably be beneficial to kind of track a running average of the road color in order to influence the HSV boundary values. This may help to prevent any road coloring that is close to the lane line coloring from interfering with the lane line colors. It would also be beneficial to have a running average of the line positions to help smoothen it and to prevent so much jittering. It would also be interesting to explore other filtering options to the original image to see if there's any way to make the lane lines consistently stand out more such that they're easier to detect rather than setting HSV boundary values for white and yellow lane line colors.